So just give me a second. Okay, sorry for the disturbance. So good evening to everyone once again. Hope you are doing good. So here we are with the lecture number 2 on wave on string. In NCRT, this chapter is named as waves, oscillation and waves. So basically, we have seen the basic terminologies in lecture 1 that is related to wave, what actually a wave is, what types of wave are there, and what types of wave we have to study. Okay. Then we have did some basic definition like amplitude, frequency, wave number, velocity of wave. These all we have done in the previous lecture. Now we are focusing specifically on the, let me show you, just a second. So if I talk about what we have to discuss today, is this. So types of wave, just a second, types of wave we have discussed in the previous lecture. Okay, propagation of wave, I think we have discussed. Now today we are going to learn about the equation of motion. Propagation of types of wave, we have two types of wave that we have discussed. Two types of, basically two types. First is mechanical, and second one is non-mechanical. Those are not mechanical, termed as non-mechanical. Okay. So in mechanical, what is the what is the key difference between them? So in mechanical wave, those wave are traveled with the help of a medium. So those wave need a medium to travel from one place to another. In non-mechanical wave, basically these wave does not require any medium to travel, and these waves are actually the electromagnetic wave. Okay. In mechanical wave, specifically we are focusing on the uh, sound wave. Okay. So I hope you got the last lecture. Any kind of doubt regarding the last session? Any new problem that occurring in your mind related to wave? I don't think so. But if you have any, you can put the message in the chat box. Got it. So today, the agenda of today's equation of wave, where to establish a wave equation, then also the basic terms in waves that we have also seen, but in a revised mode, we are going to study that also. Then speed of transverse wave and speed of sound wave. So we have the type of wave or the nature of wave. Two types of wave there on the nature. First is longitudinal, and the second one is transverse. Welcome student, how are you? So these two waves we have also discussed. So longitudinal wave, I will give you the overall summary of it. Longitudinal wave in which wave motion and particle motion are in opposite direction. So wave motion is like this. Particle motion is perpendicular to the wave motion. that wave is termed as transverse wave. But if wave motion and particle motion are in same direction, particle motion सेम डायरेक्शन में अगर है, सेम डायरेक्शन, then those wave are termed as longitudinal wave. Okay, so first thing first, I will tell you that most of the student form a picture in their mind about wave. That, let me change the screen. What they form in their mind, that this is typically a wave. Okay, so they relate all the things to this diagram which they have made in their mind. Okay, so I want to remove this confusion to you. This is not specifically represents wave. Okay, because in SHM also, if you will see, in SHM also we will plot these graphs. Later on you will study that SHM is not a wave. Then what is this graph? This graph represents the displacement with respect to time, and this displacement is of particle displacement. But wave is a collection of particles. There are infinite number of particles in the wave, which is oscillating. That is why the wave has been formed. Got it? But itself, SHM is not a wave. Got it? Although this is a good example to understand the transverse wave, because here the particle motion is perpendicular to the wave motion. Wave is traveling in this direction. Particle is oscillating perpendicular to and fro. But not restrict your mind to this picture only, because if I talk about the longitudinal wave you can also represent like this. Now some of you are thinking that how is this possible? We have studied this specifically for transverse wave and longitudinal wave. Sir is saying that this can also represent the longitudinal wave. Yes, of course, this can also represent the longitudinal wave, because this variation, this plot is of sinusoidal wave. Okay, so if longitudinal wave behaving as a sinusoidal wave, mathematically you can relate that also, because in longitudinal wave what we have specifically here, sound wave. In sound wave most of the studies focusing on the change of pressure. Change of pressure, we have seen in the previous lecture that compression and rarefaction will form in the sound wave. So if we want to represent the pressure as the function of time or the function of displacement, then we can also use this. If the variation in pressure in a sound wave following the simple harmonic motion, so we can represent this also. We can represent this as longitudinal wave. But at that time, these are not the particles. This is the pressure or density or whatever be the physical term you are observing with respect to time. But in transverse wave, this is specifically the motion of a particle or displacement of a particle at particular time. And there are number of particles, you can say, which are oscillating. I'm not saying that simple harmonically, but they are oscillating perpendicular to the wave direction. That is why we have termed this as transverse wave. So two key facts that you have to keep in your mind, there are two pointers or note you can do, is that this graph specifically not belong to wave. Okay, although it is belong to wave, but not strictly. If there is something which is not like in this form, you can also say that that is also representing wave. Okay, this was also a wave. Let me show you with example. Just a second. This is also a wave. This is a square pulses, square waves. This is also a wave, sawtooth wave. So not specifically this. Okay, this is a wave which follow sine and cosine as a mathematical variation. Okay, so the displacement of that physical quantity, because we know that in wave the disturbance is traveling from one place to another place, and that disturbance basically belongs to the momentum or energy. Either energy is traveling or momentum is traveling, or both. Because if there is energy, there will be a momentum. Okay. So what I want to tell you that specifically this graph does not only belong to wave. There are other ways also. So these ways, this is also a wave, this is also a wave. Okay. But this specific, this curvy line is a wave which following a mathematical function variation with sine and cosine, okay, trigonometric function. So that particular wave is termed as simple harmonic progressive wave, which is following in which the variation, that disturbance of energy or that disturbance of momentum is varying according to sinusoidal function. Okay, so that is the whole concept of wave. Although it is a little confusing to imagine a wave, but whenever you have to imagine a wave, try to think in terms of transverse wave, because transverse wave you have seen already. When you uh, uh, tie a rope at one end and make it oscillate from another end, you will see these types of oscillations there, these types of waveform. So it is easier for us to deal with uh, transverse wave rather than longitudinal wave, because it is hard to uh, imagine longitudinal wave. You have not seen it practically. Okay, so that is the myth I want to remove from your mind. I think I have did it, but let's see what happens. Okay, now just a second. This we have covered already, the types of wave and all. So here we are with the wave equation. Just a second, just give me a second. So we are here the wave equation. So equation of wave motion. Now before doing that, I will explain it in my own terms. Now the general equation of wave. Okay, and try to take the notes. Got it? It's really important. Now, if I talk about, let's say this is a line on which this wave is oscillating, and I have chosen the transverse wave because I have told you that it is easy to observe these waves. This axis represents the y. Y is the displacement of any physical quantity, and I will ask you what is that point should be, what is that y should be, and here we have time. Okay, now what are the possibility for y? What y could be? Could be. First option is pressure. Second is density. Third is uh, let's say electric field, or electric field. In respect to electric field, I will write voltage. And fourth is all of the above. And fifth option is none. So try to think. I have shown you a variation here. What that variation should belong. Okay. What this Y could be. It could be pressure, it could be density, or it could be voltage, all of the above, or none. And Y here represent the displacement. So if you have remember that I have taken at least 5 to 7 minutes to explain what the displacement is. Displacement you cannot refer all the time in the context of position. Okay. So Beshwaraz, I think I have pronounced your name correctly. It is Basavaraj, na? Basavaraj. Okay. So Basavaraj is saying that none. Y represents here none. And what about the JNV Ramnagar student? What is your opinion about that? Which variation is given here? Malab, Y is the displacement, and displacement is of what? Is it a displacement of pressure, density, voltage, all of the above, or none? Then I will proceed in the next. Yeah, Nikhil has also joined. So try to answer it, Nikhil. Press. What does this press mean? I don't. I'm not relating it with my question. Oh, okay. Pressure you are saying. Okay, good. Nikhil, what's your opinion? And student of JNV Ramnagar, you are keeping your opinion too silent today. So only Basavraj is giving the answer, not the okay. Nikhil is saying that pressure. Got it. So I'm waiting for the opinion of JNV Ramnagar for the fair competition. But I don't think so. They are making any. Come on, guys, you can do it. At least you have to just guess, na. And you do not need to write everything. You have to write the number 1, 2, 3, 4, or 5. Okay, no problem. So what I have told you in oscillation when we are studying oscillation, that displacement, that we have a myth about displacement, that it is only the change of the smallest distance between two positions. Okay. Or you can say that it is a quantity which is related to positions. No. Displacement is a mathematical function of time. Displacement, it is a, okay, now you have changed your mind. Got it. So it is a, what I'm talking about displacement, it is a mathematical function of time. Mathematical function of time. Which means y here represents a function which this varies with time. If that variation is periodic, so this function should be periodic. Got it? If this displacement varying with the time periodically, so that displacement should also be a periodic function. Got it? But what is the key fact here? That displacement is not all the time we told in the context of position. It could be the change of pressure with time, change of voltage with time in AC circuit, alternating current. Okay. Change of density in sound wave, change of pressure in sound wave with respect to time. So anything which is varying with time, you can relate it with the displacement of that particular physical quantity. So displacement is not a word that we should use only in the reference of position, only in the context of position. It is a word that we can use if a quantity, physical quantity, is varying with time. Got it? Now I think you got it. So pressure, the Y could be pressure here, Y could be density here, Y could be voltage. So it is 4, all of the above. And to congrats, I have to congratulate Basavraj. You have did it well. So lots of emojis for you. Got it. Now move back to the discussion here. If I'll ask you that I need to write here in this situation, in this graph, this is the simple harmonic motion, you will see, because this graph represents a sinusoidal wave and that are simple harmonic function. So particle here is doing simple harmonic motion. Let me change the color. So particle here are doing the simple harmonic motion. This particle also, this particle also, this particle also. So although I can write that here the displacement is a function of time, does it sufficient? Does it sufficient? If I go to ask you that write the displacement of a particle which is oscillating in this wave, so does anything extra do you need to require? Do you require anything extra in that case? Let me tell you once again. If I want to know the displacement equation of this particle, let's say this particle number 1. So only time that is needed to you or anything else? Tell me. If it is alone a display, if it is alone a particle, single particle, that is okay. We need only time there. Okay. This equation, y is equals to a sine omega t plus delta or phi naught. That is cool for a one particle, single particle. We have seen it. A block is oscillating about mean position to and fro. And that equation is given by this because it is a single particle. Got it? And it is also depends on only on the time. But what if this is a wave? Because wave is a collection of particles. So if I ask you to write the displacement equation, what is the first question that you are going to ask to me? Just ask it. Do not hesitate. Okay. Or let me tell you what is that question. That question is, sir, for which particle we have to write the displacement equation? That is you going to ask now. Whether we are talking about particle 1, particle 2, particle 3, particle 4, particle 5, for which particle you are talking about in the wave equation? That information you need now. Give me a thumbs up if all of you are agree. If I want to write the displacement equation or that displacement, let's say here is the pressure. So if I want to write the pressure variation of this particular point, so we need the location of that point now with respect to this axis. Okay, this will be not be time, this is x. Okay, so what we need to write the displacement equation, to write the equation of wave, we need two function, that is position and time. Got it? Because here each particle is oscillating. So first question will be which particle we have to write the equation, and let's say that particle is particle number 5. So first thing what we will do, we will reach to particle 5. A particular position is given to you, that particular particle is at x is equals to 2 centimeter, for example. So whatever the particle is present at x is equals to 2 centimeter, you will focus on that particle only. But when you reach at that particle, you will see that this particle is also oscillating with time. It's also changing its amplitude or changing its displacement with respect to time, because it is in a simple harmonic motion, or let's say any kind of oscillatory motion, not specifically single harmonic. Okay, let it imagine in a bigger way. Suppose you are here, you are standing on this, and this is the wave pulse is forming, and you are here. So I have told you this is me. So I have told you that write the equation of this wave. So you will going to ask me, sir, for which particle we have to write? Okay. So I have told you that at the particle present at x is equals to 2 centimeter, observe that and write the equation of displacement of that particle. Okay, no problem. So you have moved yourself and reached to x is equals to 2 centimeter here. And let's say this point is P. And for simplification, this point is P here at x is equals to 2 centimeter. Now you have got it here, okay, at this particle. So this particle you have to observe. But when you are taking your notebook and writing the equation, suddenly you will see that this particle is not stationary. This particle is also oscillating. This particle is also changing its displacement with respect to time. Got it? Because after some time it will be here. After some time it will be here. Because it is oscillating with respect to time, to and fro. So that there will be a spark in your mind then, and you will see, and you will write that to write the equation of wave, the particle, the displacement of wave must be a function of the x and t. We must know where the particle is. It tells us about where the particle is and at what time we have to study. At what time we need to write the displacement. So suppose in this example, at x is equals to 2 centimeter, you are here, and that particular time is, let's say, 2 seconds. So at 2 seconds, at x is equals to 2 centimeter, 2 seconds, where this particle is here. So displacement of this particle is this. Okay. So this is the context, and I will say this is the concept of the wave function. Got it? Now, if I ask you what is the general equation of wave? So general equation we have already identified. And just give me a second. So general equation of wave, or you can also say it general wave function. So it is y is equals to function of x into this. Got it? Now, this is another form of checking if this function representing wave or not. So it will be del 2y by del t square equals to v square del 2y by del x square. So this is the equation of traveling wave. if any function of y which is in x and t satisfying this condition, that should be the wave. Okay, got it? So we will check it. Recently we have did that y is equals to a sine omega t. Recently we have studied it. In the weekend we have also seen the question in that. So this is a simple harmonic function of a particular point which is oscillating simple harmonically. Now, let me check that is this represents a wave or not. So what we are going to do, we will differentiate it. This is the del operator, partial differentiation operator. So are you guys aware about the partial differentiation or not? Have you any idea what is this partial differentiation and how to proceed with it? Just give me a yes and no. I will tell you quickly here. Okay. And have you know the differentiation? Like this one, you can did it. D by dx of x square. Can you did this? What is the answer of this? Tell me. Just tell me. Very good. 2x. So what is the difference in partial differentiation? Let we have a function x square plus t square. Y is equals to x square plus t square. And if I'm writing that del y by del x, so only what you have to do, you have to, or with respect to what you are differentiating, we are differentiating with respect to x. So only x you have to consider as variable. Other things that is written here, you need, no, it is not 2x plus 2t. Okay, listen to me first. If you are differentiating it partially with respect to x, look at the operator. It is not d, it is del. Okay, there is a difference in between them. So if it is del y by del x, which means you just need to focus on x square. So only the function which is in x, you will consider variable. Other function which is written in the expression is constant for you. So let me do it. So del y by del x, the differentiation of only x we have to treat as a variable. So differentiation of x square will be 2x plus this t square we will consider it constant. So differentiation of it will become 0. So answer will be 2x. Same way may try to do this del v by del t. Try to do this. And what is the answer? Tell me quickly. No, again 2x. How you can say? Matlab, 2x is not the answer. Not 2 because okay. Listen to me first. When you are differentiating partially, here we are differentiating partially with respect to time. So only that term which is written in terms of t, you need to consider variable. Other thing is, rest of the thing is constant for you. So in this expression, this t square is variable for b, so it will become simple like d by dt of t square. So it will be 2t. And another thing is what? Constant. So differentiation of any constant will be 0. So answer of it will be 2t plus 0, which is 2t. Got it? Try to do this x cube plus 3t square and find out del x by, sorry, this is y is equals to x cube by 3t. So find out dy by dt and dy by, sorry, del y by del t and del y by del x. Find out what is the answer. Student of JNV Ramnagar, you are not making any single response. What is the problem with any connectivity issue, or you are not getting the answer? 6x plus 60. For what? For this one, dy by dt, or for both? I think you have did it for both, but do not add the plus sign. Okay, I'm not telling you that it is del y by dt plus del y by del x. If you are getting del y by del t, you have did it very correct. So x cube will be the constant for you. So differentiation of x cube will be 0. 3t square, which means 2t into 3, which becomes 60. Yeah, absolutely correct. Very good. You got it very correct. Brilliant. Now it is easy for you to understand the differentiation, this equation of traveling wave. So I'm asking you, student of JNV Ramnagar, what is the problem? At least you guys need to be to the response, no? The class, the more responsive will be the class, the more engaging it will be. Okay. Now we will find out, this is the equation of SHM of a particle. We have did it in the previous class. So we will checking it that is this a equation of wave or not. Okay. So to check what are the equation of wave represents, by this del 2y by del t square, v square, v here is the wave velocity. It is the wave velocity. I think any kind of connectivity issues there for student of JNV Ramnagar. So y is equals to a sine omega t. Firstly, we will find out del y by del t. So del y by del t. Okay, your chat box is not opening. Okay. That might be a technical error there. Now it is opening, na? You are sending me chat messages. Now it's good, na? So try to find out del y by del t. What is the answer? The difference a is a constant, sine omega t. Differentiation of sine omega t will be cos omega t. So it will be a omega cos omega t. Because omega you have to differentiate omega t separately. Now try to find out del 2y by del t square again. So a omega is a constant, cos omega t is a variable. So you need to differentiate it. It will become minus a omega square sine omega t. Okay, this one. Now we need to find out del 2y by del x square. For that, firstly we will found del y by del x is equals to del by del x of a sine omega t. Now what I have told you just few minutes ago, that for partial differentiation with respect to what you are doing the differentiation, if it is present, take it as a variable, and another thing will be taken as constant. So here in this expression there is no x term, only time term is related given here. So time will be considered constant with respect to x. So differentiation of this will become 0. So our equation will become 0 here, because this del 2y by del x square is 0. This equation is like del 2y by del t square, v square into 0, and something divided by 0 will become undefined. So we can say that this equation, this SHM, is not a. So we can say that SHM is not a wave. But look the beauties of the physics. SHM of a single particle itself is not a wave, but collection of particle is a wave. Because in a transverse wave, if you will see simple harmonic progressive wave, all the particle is doing SHM about the mean position. So collection of particle doing the SHM will form a wave, and that will also satisfy the equation. But Only single particle, if you talk about, that will not represent a wave. So this is very important. Okay. Try to take the notes of it. Then we will proceed further. Got it? Now, one question that is arising in your mind, that every time we need to differentiate it like this, that will be a hectic process. So let me tell you a trick to find out that which function belongs to a wave and which function does not belong to a wave. Okay? Each time do, but if there is something which is not matching with this trick also, then you need to move to the conventional method, which is the del 2y by del t square equals to v square del 2y by del x square, where v square is the wave velocity, which is given by omega by k. Okay, omega by k. We have did it in the previous session. K is the wave number here, 2 pi by lambda. Now, so if any function, just write it down. If any function is in the form of y is equals to ax plus minus bt, that represents a wave. Okay, but condition is that y should be defined for all the values of x and t. Okay, got it? This v should not also be zero here. V cannot be zero, because we have seen very first example that we have solved, y is equals to a sine omega t. It has this value 0, so that is why the equation is not satisfied. So v should not be 0. Got it? So you have noted down? Give me a thumbs up. Basav Raj and student of JNV Ramnagar. Yeah. Okay. So now we will take some functions and try to establish it. Y is equals to ln 5x plus 3t. First is this. Second is y is equals to, very famous example, y is equals to, I think, e raised to the power x minus vt whole square. So these two examples we are going to cross verify whether this represents a wave or not. Okay. So firstly, we will talk about this. So y is equals to ln 5x plus t, 3t. Now you will see that it is somehow matching the profile ax plus minus bt. But there is another condition also, that y should be defined for all the values of x and t. Suppose if this value goes to be negative, ln something negative here, we can put the values of x and t such like that the expression inside it will become negative. But negative of log is not defined. So it is not defined. You know it, na? Negative ln or logarithmic of negative numbers is not defined. So it is violating the rule number 2. So that is why this equation does not represents the wave. Okay. I will do it by my own. Y is equals to e raised to the power x minus vt whole square. Meanwhile, you will did this. Y is equals to check this function. 5x minus 3t raised to the power 3. Tell me about this function, whether it is representing a wave or not. Or how to check it? Firstly, first method is that it should be a function of form ax plus minus bt. That is satisfying the condition. Second is put x is equals to 0, t is equals to 0, for which see the function is defined or not, y is getting a defined value or not. If it is, then okay. Then put for higher values, put x is equals to infinity, y, t is equals to also infinity. Then see if y is showing a defined value or not. If it is, then it is a wave equation. Tell me yes and no. It's very easy. Yes and no. Tell me rapidly. Do not trying to do this with this equation del 2 y by del t square. Okay, so Basavaraj is saying that it is a wave. Okay. And what about JNV Ramnagar student? What is your opinion, guys? So your chat box is working now, na? Okay. So let we deal with this. Y is equals to 5x minus 3t whole cube. If we put x is equals to 0, y t is equals to 0. So this equation becomes 0. 0 minus 0 raised to the power 3 will become 0. So y is 0. That is a defined value. Okay, no problem with that. But what if x is equals to infinity, y is equals to also infinity, t is equals to infinity? So it will become infinity minus infinity. Infinity minus infinity is not defined. Got it? What is this ND means? Either it will be yes or no. What is this ND? Not I'm so sorry. Not defined. You're using the abbreviation. Smart. Got it. So it is not defined for higher values, but it should be for all the value. For is to be a wave, it should be valid for all the values of x and t. That is violating the rule number 2. So this is not a wave. I hope you got it, Basavraj. Where have you did the mistake? Hmm? And do not problem with that. Do not uh, take so much of stress. Oh, I'm getting it wrong or not. Okay. First time it will happen to all. And it will happen to me also. It has happened. Now, if I talk about this function, second one, y is equals to e raised to the power x minus vt whole square. Meanwhile, you guys can do it also. It is minus x minus I have added extra minus x minus vt raised to the power 2. Okay. So let's say this whole function x minus vt is 0. So e raised to the power 0 will become 1, and 1 is a defined value. You know, na, e raised to the power 0 will become 1. Okay. And this is a defined value. So for no problem with 0. But if I put this function get a value of infinity, so this will become e raised to the power minus of infinity square. Infinity square is infinity. e raised to the power minus infinity. 1 upon e raised to the power infinity. E raised to the power infinity is infinity. 1 upon infinity is 0. So that is also a defined value. Okay. What about if I put the value here is minus infinity? Plus square minus outside. Again, minus infinity square will become plus infinity. Okay. And then again plus minus minus. Again it will getting e raised to the power minus infinity. 1 upon e raised to the power infinity. It will become this and 0. Which means for both the values, for 0, higher values and lower values, this y is defined for all the values of x. So we can say that this represents a wave equation. Wave equation. Look how complex equation is this. Does this require, does this a equation of SHM? No. SHM is only a drop in the ocean of wave. Okay. So this equation does not look like SHM, but it is a equation of wave because it is satisfying the condition. Got it, everyone? Any kind of doubt in this? Basavraj, you are very responsive today. Well, I'll appreciate your effort once again. And you guys also, student of JNV Ramnagar. Now, if anyone has any kind of doubt in this, they can ask. Anyone? Any kind of doubt? Okay. So I'm giving you a homework. I'm giving you a homework here. You need to check that y is equals to 1 upon 5x plus 3t. This function represents a wave or not? Wave. And let's say the square of it. It would be easier for you. Wave or not a wave. And second function is y is 1 upon 5x plus 3t. So these two functions you need to check. I will discuss it in the next class. Meanwhile, if you have any kind of doubt, you can ask. Otherwise, it's a nice session with you guys. I really enjoyed this session. I hope the same for you, that you have also enjoyed the same. Thank you so much, guys, for being attentive. Any kind of doubt, if you have, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive. Okay. Take care of yourself. Okay, so you have answered it already. One is yes. Okay, you're absolutely correct. But for second, we need to check and we will discuss it in the next class. Good to go. Thank you so much. Bye-bye. Take care.